All right, let's do it. Okay, so I've got solid copper sphere.
So what's happening?
0.25. That's a terrible sphere. Sorry. 0.25 centimeters. I've got around the outside. I have 25 times 10 to the negative 9th coulombs. Agreed? Okay, it's spread around evenly because it's a conducting sphere and it's a symmetric sphere in spite of my drawing. So therefore, all the may be spread out equally along the surface. Good. Okay, so it says find the electric field at the following distance from the measurement center. So since it's an isometric arrangement, we're going to go Gauss. It's not one of the four shapes we know how to do otherwise. So we're going to go integral E dot dA is equal to Q enclosed over E naught. So the charge enclosed is going to be how much in the shape I'm going to draw? I'm going to draw one at 14 centimeters. Or, sorry, 0.25 meters, right? 0.2. What's the first one? 0.24. So I'm going to draw one 0.24. So what's my charge enclosed? 0. So I'm already done with this one. My electric field is going to be 0. I don't even have to do a step. You guys good over there?
Yeah.
Because that's a huge, profound moment that we need to talk about in a moment. So I hope you got that.
A equals 0.
A equals 0, right?
Yeah.
Good. Okay, let's move forward. Next piece of the puzzle. I'm going to do 0.26. Right? Go to 0.26. So what do I get there? I got my charge enclosed. It's going to be what this time, sir? 25 times 10 to the negative 9th over E naught, which is 8.85 times 10 to the negative 12th. Electric field is going to be what I'm looking for. The area of a sphere that I drew would be?
Going to be 4 pi r squared.
And R is going to be what in this case?
0.26.
0.26 squared. Solve for the electric field.
So why doesn't it matter? Radius.
If it's concentrated as a dot or spread out over a surface, it's going to be the same effect, is it not?
So is that it?
Well, you got to solve for it. You got to put everything in this. That's the hard part, Peter. Solve for it. That's pretty easy. Good. Okay, and then 8.85, and how are you going to change the sphere? We're hollow. Would it make a slight bit of difference? No, because it's treated exactly the same way. Now, before you put away your stuff, one other thing. The electric field at this point was what?
At which point?
Inside the sphere?
0.
It would also be 0 here, 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 here. Electric field is going to be 0 inside of a conductor. Why?
Because it's the same with the homes.
Right, because also in addition to that, if it's not 0, what happens to the charges? What are they going to do? They're going to move some which way until they mellow the whole thing out, right? Because there's an electric field going on in here. These electric charges are going to start moving until they get it all settled. Okay? Does that make sense? Yes, sir?
So why would it matter if it's uniformly distributed like throughout the wall?
It would not be the same because these would be repelled more than these, and so they'd be pushed out towards the edge. So they keep getting pushed out towards the edge until they all end up on the edge. The farthest they can possibly get away from each other is to arrange all of them along the edge.
No, but like if it's non-conducting.
Non-conducting is a whole different ball game, which leads us to number 17. So before you go, let's talk about 17 briefly because you're going to do it for your homework. 17 is a solid sphere of radius 20 centimeters with a total charge of 12 microcoulombs uniformly distributed throughout the volume. How's that change things? They're not on the edge anymore. Hey guys, teaching something you're going to run into and go, I don't know how to do this.
Okay.
Okay? Trying to save you some time. So, if it's not distributed along the edge, that means the charges are uniformly throughout the thing. So now outside, is it going to matter? Charge enclosed, charge enclosed. And since it's symmetric, I'm okay. Inside, what happens?
You have it.
I have some that are in and some that are out. And it's going to be your job, given the fact it's uniform, to figure out how much is inside. Now, I'll give you a hint. You're going to use beta for the first time. Beta is what? Charge per unit volume times volume would give you how much you have enclosed, right? So your charge per unit volume times the volume that you are drawing. Now again, that means that volume is going to appear on both sides because that's the volume of the shape you're drawing. not the volume of the whole entire thing. All right? So for homework, I want you to try all the way through to 6 on 1211. If you do that, we will have a chance at not going crazy before the quiz. Let me see here. If you try that, we got to talk about those problems. Okay, so we'll talk about those problems, then we'll take the quiz. So if you're trying to think ahead, your quiz is going to be